Hello my dear students, welcome back to Learn Physics. In today's video, we are going to discuss about some of the kinematics questions. That is exercise questions we are going to do. So last class also we were doing some exercise, and today's video also we will be doing some of the exercise questions. Okay, discussing some questions. Okay, here first question is, an open lift is moving upwards with a velocity 10 meter per second. It has an upward acceleration of 2 meter per second square. A ball is projected upward with velocity 20 meter per second relative to ground. Find time when ball again meets the lift. The displacement of the lift and ball at that instant, distance travelled by the ball up to that distance, take G as 10 meter per second square. So in this question, open lift is moving upwards with a velocity of 10 meter per second. A lift is moving upward with a velocity of 10 meter per second. Then it has an upward acceleration of 2 meter per second. So initial velocity is 10 meter per second, acceleration is 2 meter per second square. Then a ball is projected upward with a velocity of 20 meter per second square. So ball is moving upward with a velocity of 20 meter per second relative to the ground. Find the time when the ball meets the lift. So first we need to find out the time when ball and lift meet each other. Second one, displacement of lift and the ball at that instant. At that time, what is the displacement of the ball and displacement of the lift? That one we need to find out. Distance travelled by the ball up to that distance. So what is the distance travelled by the ball? Distance travelled by the ball we need to find out. Okay, so in the question, a lift is moving upward and with an acceleration, and ball is also moving upward direction. While it is moving in the upward direction, acceleration will be equal to minus 10 meter per second square. So here both are moving upward direction. So this is ball from ground and this is lift. Here ball has more acceleration than lift. So at one point of time it can meet, right? When both are moving upwards, at one particular point maybe it will meet. Or what will happen? See, this will be moving upward and while coming back both can meet. Okay, any one thing can happen. So when the time ball and lift meet each other, when they are meeting at the same point, so lift and ball, when they are meeting, so that time displacement of lift will be equal to displacement of ball with respect to the ground, right? Displacement will remain same. So we will find out the displacement of the lift. S is equal to ut plus half et square. Therefore 10t plus half into 2 into t square, and displacement of ball will be equal to 20 into t minus half into 10t square. So we can equate these two. Therefore 10t plus t square equals 20t minus 5t square. Therefore 10t equals, we are getting it as 10t equals 6t square. Okay, therefore we are getting it as 6t equals 10 by 6, or it will be 5 by 3 seconds. So this is at this time both will be meeting each other. So at time what will be the displacement of ball and lift? So both are equal. So in any one of the equations we can substitute the value of t, 10 into 5 by 3 plus t square. 25 divided by 9. Therefore, in 50 by 3 plus 25 by 9, it is equal to 150 plus 25 divided by 9, 175 divided by 9. This much meters it will be traveling. Okay, so this is the displacement of the ball that will be equal to the displacement of the lift. Next, we need to find out distance travelled by the ball. How can we find out the distance travelled by the ball? See, I told you initially itself, see, there is a chance for meeting. See, when the lift is moving and a ball is moving, what will happen at one particular point, since the acceleration of ball is more, at one point there is a possibility of meeting the lift. And another one is, ball will be reaching to the maximum height, and during the downward motion it can meet. Right? So, how can we find out whether it is the if it is in the upward motion itself, what will happen? Displacement will be equal to distance. But maybe if both are meeting along the downward motion of the ball, then we can't say distance will be equal to displacement. So, first we need to verify during which motion, whether it is upward motion or downward motion, both are meeting each other. For that, what should we do? Before that, one question we did in the same way. How will we be doing? We will be finding out the time required for reaching to the maximum height. Okay, when the velocity becomes equal to 0, the ball will be reaching to the maximum height, right? So at what is the time? We will find out the time. Time required for the ball to reach the maximum height. For that, final velocity will be equal to 0, and for the ball, final velocity is equal to 0, and initial velocity is 20 meter per second, and acceleration is minus 10 meter per second square. Then how can we find out the time? V equals u plus at. Therefore, 20 equals 10t. Therefore, t is 2 seconds. So it is reaching. The ball will be reaching to the maximum height at 2 seconds. So when they are meeting each other, they will be at 1 point something distance only. So if this is more than 2, then we can find we will be understanding that during the downward motion of the ball only it is meeting. But here the the meeting time we got it as 5 by 3 seconds. After 5 by 3 seconds, both are meeting each other, and the time required for upward motion to the maximum height, that is 2 seconds. Since this is more than the time they are meeting, so during the upward motion only. That is why distance of the ball will be equal to the displacement of the ball, which will be equal to 175 divided by 9 meters. Okay, clear? So this is how we will be solving. Clear? Next question is, particle starts with an initial velocity and passes successively over the two halves of a given distance with constant accelerations a1 and a2 respectively. Show that the final velocity is the same as if the whole distance is covered with a uniform acceleration a1 plus a2 by 2. So here a particle starts with an initial velocity and passes successively over the two halves of a given distance with constant acceleration a1 and a2 respectively. So a particle is starting from here, and two halves. So first half it's reaching till here. This is the second half. Okay, this is the first half and this is the second half. During this time it is traveling with an acceleration a1 and a2. That is, here if v1 is the initial velocity here, v2 is the final velocity over here, and in the next stage v2 is the initial velocity and v3 is the final velocity. Right? Then here show that final velocity is same if the whole distance is covered with a uniform acceleration of, so this will be equal to v3 itself. Okay, this will be equal to V3 itself if it is acceleration as A1 plus A2 by 2. Okay, so this is the question. So how can we find out this? So initial velocity is V1 and final velocity V3 itself. So here, how can we find out the velocity? Initial velocity, here V2 square equals B square equals U square plus 2AS. Initial velocity V1 square plus 2A1 into S. Okay, this half of this one I am taking it as S, and then V3 square equals V2 square plus 2A2 into S. Okay, this is the first equation. In this, instead of V2 square, I can substitute this value, right? Therefore, V3 square equals V1 square plus 2A1S plus 2A2S. So, while combining, we can write it as 2S into A1 plus A2. Okay, now I am considering this equation. Okay, here when I am considering this equation, I will get it as V3 square, that is the V square equals U square plus 2 into AS A1 plus A2 divided by 2 into S. What is the total distance over here? That is 2S. Here it is, this much is S and this is S. Therefore 2S. So here we will get it as V3 square equals V1 square plus 2 into A1 plus A2 into S. So this is from the second stage. If we are using the same acceleration only throughout, then the final velocity will be same as the V3 only. And here if we are using A1 velocity, A1 acceleration and the second half A2 acceleration, then also final velocity will be V3 only. This one you can understand, you should keep in mind as a formula also. See, initially it is both are starting with the same velocity. First half it is moving with a particular acceleration, second half it is continuing with another acceleration and reaching to velocity V3. Okay, instead of that, if throughout if they are using A1 plus A2 by 2 average acceleration, then the initial and final velocities will be remaining the same. Okay, so this acceleration will be A1 plus A2 by 2. Here we proved that both velocities, see this acceleration will be, if A1 and A2 are the acceleration like that, then the whole journey is with the same acceleration A1 plus A2 by 2, then also we will be getting the same final velocity. V3 will remain same. Okay, clear? Next question is, in a car race, car A takes a time t less than car B at the finish and passes the finishing point with a speed V more than that of the car B. Assuming both the cars start from rest and travel with constant acceleration A1 and A2, then show that V equals root A1 A2 into T. Okay, so we are going to explain the question. In a car race, car A takes time taken by A is less than the time taken by B. Okay, how much less? It is T less. Okay, so time taken by car B A is less than the time taken by B. Okay, so TB will be equal to TA plus T. Okay, time taken by B will be T greater than time taken by A. Okay, now and passes the finishing point with a speed V more than that of the car B. So velocity, final velocity at B is less than final velocity of A. That means velocity of A will be equal to velocity of B plus V. Okay, so I'll read that sentence once more. In a car race, car A takes time t less than that of b. TB minus T will be TA. That is TB equals TA plus T. And at the finish and passes the finishing point with a speed V more than that of the car B. Okay. So final velocity of A will be equal to VB plus V. And both are moving, assuming both the car starts from rest. So initial velocity of A is equal to initial velocity of B is equal to 0. And its acceleration is A1 and A2. Acceleration of A is A1 and acceleration of B is A2 respectively. We need to show that V equals root A1 A2 into T. Okay, how can we find out starting point and finishing point? Both distance travelled by the cars will be equal. That is, displacement of A will be equal to displacement of B. How can we find out displacement? UT plus half AT square of A will be equal to UT plus half AT square of B. Right? So what is U is 0. Therefore, half into A1 into T of A. T of A, I am writing it as half A into T of A square equals half into A2 into T of B. How can we write TA plus TB, TA plus T the whole square. So here we are cancelling half and half, then we will get, so this one I am writing it as root A1 into TA will be equal to root A2 into TA plus T. Okay, so here we don't know what is TA, right? For that we will write it as here TA, an equation for TA we can write it. So root of A1 minus root of A2 into TA will be equal to root A2 into T. Therefore, TA is root A2 into T divided by root of A1 plus A2. Root of A plus root A2. Now we need to find out an equation for TA. How we can find out the velocity? TA. Velocity of A is equal to acceleration of A into, acceleration of A is A1 into T. Velocity of B is equal to A2 into time taken by B. Okay, this is time taken by A. V equals A2 into TA plus T. Right? So therefore A2 into, what is TA? Root of A2 into T divided by root A1 plus root A2 in plus 1 into T. This one, when you are solving this one, this equation, you will get it as V equals root of A1 A2 into T. Okay, so this is how we are finding out displacement by A is equal to finishing point and starting point are same. So displacement is same. So we are finding out TA, and in this equation we are substituting value of TA and finding out the final equation. Okay, so these are some of the equations, and in my next videos also you can expect such kind of simple problems. How can we solve that? Okay. So I hope today's video is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.